Hello everyone. Welcome to video lecture series of Computer Organization and Architecture. Today's topic is Asynchronous Data Transfer. In this video, I'll be telling you what is asynchronous data transfer, what are the methods for such kind of data transfer, what is strobe control, what is handshaking. Then I will explain you about the asynchronous serial transfer and the communication interface. Let us begin. To start with, first you have to understand what is asynchronous data transfer. See, with the term data transfer, you must be aware with what is data transfer. So what happened when you're talking about a digital system? So in any digital system, the internal operation that is actually synchronized with the help of the clock pulse. When clock pulse is supplied, then all the internal operations can take place. Means the data transfer between the registers within a unit can take place with the help of the clock pulse application, and this clock pulse is generated by common pulse generator. So when the clock pulse is applied, then only the internal operations take place. Now, to understand it in more detail, let us take two units of any digital system. Means one CPU and other is the IO interface. If these two units are designed independently, then means the registers which are related to IO interface, the registers which are related to the CPU interface, if these two registers, means if these two units, they share a common clock, right? Then the type of data transfer that is known as a synchronous. Means when there is a common clock. But when there is an independent clock, one for the CPU register, other for the IO interface. So that means there is a private clock which is related, which is associated with each and individual unit. So what happened in majority of cases, the internal timing of units, means CPU or IO interface, they are independent of each other. Means they don't have any relation, any dependency. It means they uses private clock. So in such kind of condition, when the two units, they are having their private clocks, means they are asynchronous to each other, right? And in this particular case, the kind of data transfer that is known as a asynchronous data transfer, and this is widely used, you must remember. Means in this particular case there is a private clock, right? So what happened when we are talking about the asynchronous data transfer, means data transfer between two independent units that requires some kind of control signals also. Why control signals? Means that will gives us the indication here in terms of the time, means at which the data is to be sent. Control signal is what? If I'm speaking, you are listening. So before speaking, I can send a any kind of signal that can be treated as a control signal. Or when you are receiving a phone call, so before starting conversation, you are getting a ringing tone. That is what a control signal is. It means when we are talking about asynchronous data transfer, there is a requirement of the control signal, right? So that also I'll talk in detail. But corresponding to this mode of data transfer, which is the asynchronous, there are two methods. Means there are two techniques via which asynchronous data transfer can take place. First is the strobe control. What is a strobe control? Means strobe pulse, a control signal. A pulse is supplied by one unit, and that will gives an indication, means when to start the transfer, when to start the data transfer. Means strobe pulse is supplied by one unit, will gives the indication to the other unit at which time transfer has to occur. And the second method is what? The handshaking. Handshaking, from the term itself it is clear, means if you are doing the handshaking, means there is the involvement of two persons. It means if the unit is transferring some information, other unit is receiving, so other unit will respond to a with a signal, means about the acknowledgement. So in the case of the handshaking, there are two control signals. If I'm speaking, I'm asking, are you able to hear me? And you are giving me the acknowledgement, yes or no. So yes or no is what the like acknowledgement you are giving. It means in response to the one control signal, other acknowledgement is being given. So handshaking method that is commonly used to accompany the kind of data transfer with the help of the control signals, right? So this is a very important, very interesting unit. Now, both the methods, it doesn't mean that the handshaking is only used or the stroke control is used. Both of these methods, right, they are used actually. And here, as if means when the information is being transferred, data is being transferred, the overall transfer can be depicted with the help of a sequence. So the control sequence during an asynchronous type of transfer, it will depend who has initiated the transfer. Either source has initiated the transfer or destination. It means there are two transfer methods. If source has initiated, that is known as a source initiated. If destination has initiated, so that is known as a destination initiated. So in both of these methods, the strobe control and handshaking, will be talking about these two. First is the strobe control. Strobe control method means it employs a single control line. Control line. You must remember this is the control signal to indicate the time at which transfer starts. And this control line, this is known as a strobe. And the strobe can be activated either by source or destination. So if strobe is activated by source, that is known as a source initiated strobe. You can see in this particular diagram, there is a source unit, there is a destination unit. Strobe is initiated by source here. So this is what source initiated strobe for data transfer. If you see this particular diagram, you can see from this timing diagram also, source unit first places the data on the data buses, right? Source unit places the data on the data buses. Along with, you must see this timing diagram. After a certain delay, when we are ensuring that data is actually resolved to a stable value, then source initiate a strobe pulse. So you can see here strobe is initiated after a certain delay, right? Means source activates a strobe pulse. It means the information on the data bus, information is available on the data bus. You can say this is what the valid data, and the strobe control signal, it remains active for a sufficient time, and during this particular time this destination unit will receive the data. And you can see this is the falling edge of the strobe signal. So the destination unit, this particular unit, it uses falling edge of this strobe control to transfer the contents which is available from the data bus into its internal registers. Then source removes the data from the data buses, and when source removes the data from the data buses, it disables strobe signal. You can see here strobe signal is disabled. So when there is a requirement to place a new data on a data buses, so new data, new valid data will be available on the data buses only when this strobe signal is activated again, right? You can see along with this falling edge, the data is being transferred, then this is in inactive mode. So strobe may be memory write control signal from the CPU to a memory unit, right? So this is how you can explain it. Now let us see about the destination initiated strobe. In this particular case, you can see destination has initiated a strobe signal. So in this particular timing diagram, you can see destination unit first activate strobe signal, right? When this particular strobe signal is active, and then only source unit will respond and it will places the data on the data buses, and this particular data will be available for a enough duration so that destination unit can accept it. And along with the falling edge of this strobe pulse, again it can use to trigger the destination register. Means destination unit disable these strobes, you can see. And finally source remove the data which is available over here. Source will remove the data from the data buses. So in this particular case, first destination unit has initiated a strobe, then only source unit is placing the data. So this particular kind of case you can observe for the memory read control from the CPU to a memory unit. This is what you can make a note. Coming to the next, which is about the handshaking. As I have told you, handshaking means when there is some exchange. If you are doing the handshaking with the other person, means you and the other person has means initiated, right? Then only. So what happened till now? We have discussed about the strobe control method, but the strobe control method has the disadvantage. Whether the strobe control is initiated by source unit or it is initiated by destination unit, means one unit is initiating, one unit is transferring the data, but the other unit don't have any control, don't have any information. See, other unit is receiving the information, but the first unit is not aware whether the data has been transferred successfully or not. Means if source unit has initiated the transfer and destination is receiving, but source unit does not have any control or any information whether the destination has received the data which was placed on the bus or not. Similarly, for the destination unit, it means data has been placed on the data buses, other unit has been informed, but there is no information. So this particular problem was resolved by the handshaking method, which is what I'm going to discuss. So in the case of the handshaking method, there are two control signals. One control signal if the data transfer is in this particular direction. So one control signal is in this direction and other control signal, which is the acknowledgement, that is in the opposite direction in this particular manner. If this is the data, right? So that is what the handshaking means. One control line that is in the same direction where data flow and the other control line is in the reverse direction. Here you can see this is the source initiated transfer using handshaking. So you can see here is a data bus, means data is available on the data buses. Data valid line is one control and the other control is the data accepted, which is being sent by the destination unit. Means here there are two control signals, data valid and data accepted. You can see source is transferring a data which is received by the destination unit. So in this particular timing diagram, you can see the timing relationship what exchange of signals in between the source and the destination unit. First you can see source unit that initiates a transfer. How this transfer takes place? By placing the data on the data buses. You can see valid data is being placed, and when this data is being settled, then source initiated a transfer by placing the data and generates or send an enable signal, means data valid. You can see after a certain time data valid signal, it will gives an indication to the destination unit. Destination units, what is this doing? It is then activating the data accepted signal when it accepts the data from the data bus. So you can see first data is being placed on the data buses, then this particular signal is being like provided, sent to the destination unit, and when destination unit receives the data, then data accepted signal is sent back by the destination unit. And when this data transfer takes place, then source unit disables the data valid signal. When source unit disables the data valid signal, it means it cancels the data from the control buses. As soon as the data valid signal will be disabled, data will be cancelled from the data buses, and then this data accepted line will also be gone on the initial stage, right? It means source unit is not capable to send the next data till the time destination unit is showing its willingness. If you talk about the sequence of events, what is the sequence of event? First, source unit places the data on the data buses. After this, data valid line is enabled. When data valid line is enabled, this particular line is enabled, it means destination unit, it accepts the data from the bus. When it accepts the data, it will generate the data accepted signal. You can see data accepted signal. Then after the completion of accepted the data, it will disable data valid. You can see data valid line is disabled, data bus is disabled. Then data accepted will be disabled, and now it will be in the initial stage. So this is what about the source initiated transfer using handshaking. Second type of method, which is about the handshaking. From the term handshaking, it is clear that means there is an involvement of two control signals, as if you are doing the handshaking with the other person, other is also involved. So you can see in this particular diagram here, data is being placed on the data bus. There is a data valid line and ready for data. So this data valid and ready for data, these are what two control signals. Ready for data line is used in place of the data accepted, which is being like mentioned in the earlier case for the source initiated. Right. So here destination transfer is initiated. Means information is being transferred from source unit to the destination unit. So what will happen? First, destination unit will show its willingness that it is ready to accept the data. So you can see at this particular time, this particular line is active. When it is ready for data, ready to receive the data, then data is being placed on the data buses, and when data is being placed, then data valid control signals is being activated, and which is giving an indication to the destination unit. As you can see the sequence of events, first destination unit has shown its willingness that it is ready to accept the data, means it will enable ready for data line, this particular line, right? Then data line means data will be available on the data buses. This is the second step. And after second, it will enable data valid line. When destination unit will accept the data from bus, and after accepting the overall data, it will disable ready for data. So you can see ready for data, this will be disabled first. Then data means at the same time, means when it is not willing to achieve, willing to gather further information, data bus will be inactive and data valid line will be inactive. So it will disable both data buses and data valid line. So this is how you can explain the operation of the handshaking mode. Now the next point, which is about asynchronous serial transfer. See, asynchronous transfer you are aware with. So when we are talking about transferring the data, so data transfer can be done in two ways. It can be done either in serial mode or in parallel mode. So in the case of the serial data transmission, one bit is being transmitted at a time. So if message contains 10 bits, then one bit, then one bit, then one bit, means a sequence of 10 bits will be transmitted. But in the case of the parallel data transmission, overall message has been sent at the same time, means all the 10 bits will be transferred at the same time. So if you compare serial transfer and parallel transfer, so parallel data transfer, that is quicker. Parallel data transfer or transmission can be used for short distances where speed is actually the requirement. So if we talk about serial transmission, that can be done in a synchronous or asynchronous mode. Synchronous means when the two units have a common clock frequency, and asynchronous when both the units have a different clock frequencies. So now we have to understand how this serial transfer can takes place and how a transmitter character can encounter by receiver with the power of the transmission rules. So you can see in this particular diagram, this is the asynchronous serial transmission. So now you have to understand how this transmitted character can be encountered or can be understandable by the receiver. So what happened? You can observe there is a start bit, character bits and the stop bits. So to inform other devices, when there is a requirement to transfer the data from one device to the other device, so the device which is going to receive the data, so that particular device must be able to get the information about the start and end bit. Means that particular device needs to understand when there is a start of information, when there is a end of the information at the receiving end. So start bit, this particular bit 0, this is start bit is denoted by 0, and stop bit, this is denoted by 1. So start bit is always means first this 0 is being sent, and after 0 the character bits are always transmitted, right? So you must remember that start bit is denoted by 0, stop bit is detected when finally line returns to state 1. 1 means at this particular stage there is no data transfer, and when a character is not being sent, so that particular line will always be at the state 1. So start of character is detected by bit 0. The character bits always come after this start bit, and after last bit, right after last bit of the character, the state of line will be at logic 1, at state 1. So this is what the rule transmitted character can be encountered, and with the help of these rules only receiver will get to know when there is a start of the character message and when line goes from 1 to 0 or 0 to 1. So this is about the asynchronous serial transfer. Now coming to the last, which is about the asynchronous communication interface. Asynchronous communication interface means it can function both as a transmitter or a receiver, and when it is going to perform as a transmitter, when it is going to perform at a receiver, that is done, and that means that particular mode is only being selected or by transferring the control byte which is loaded into the control register. So on the basis of this, the mode of transfer is going to be selected. This is the diagram which shows the asynchronous communication interface. You can see there is a bus buffer, there is timing and control unit, 4 registers, transmitter register, control register, status register, receiver registers, shift registers, right? So as you can see in this particular diagram, the interface, as I've told you, that is initialized for any particular mode, whether it is a transmitter or a receiver, just by putting the control byte into the control register. Transmitter register, you can see this is the transmitter register. It accepts a data byte from the CPU with the help of the data buses. You can see transmitter register will accept the data, and transmitter register, which the data or the byte which is available in this transmitter register, that is shifted to the shift register for the serial transmission. And the receiver portion, you can see over here, it receives serial information into the shift register. When the overall data is being accumulated in the shift register, then it is transferred to the receiver register, and from this receiver register the CPU can select the data. The CPU can read the data by read the byte through the through the data buses. That is why you can see here data buses are bidirectional. You can see here is a status register. So the bits in this particular status register, they are actually used like for flags, some kind of flags which indicates the error during the transmission. So it holds that particular information. So what happened? CPU can read the status from the status register to check about the flag bits, and it can determine the different types of errors which have been encountered during the transmission. I'll be telling you there are 3 types of error. Here you can see chip select line. Chip select line is active high. It must be 1. So chip select line that is used to select this particular interface through the address bus. There is a register select, RS, you can see. Register select that is associated with read and write controls. You can see in this particular truth table, register selected, that is a function of rs value, read and write. As you can see, chip select is active high, so it must be 1. You can see chip select must be 1. rs register select may be 0 or 1. So depending upon, you can see write and read. So here you can see two registers are write only and two read only. Write only means transmitter register and control register. Read only receiver register and status register. From status register, the status of flip-flops can be read. From receiver register, the data which is to be retained by CPU, that can be read. Right, in the control register, control byte is to be stored. In the transmitter register, data from the data buses is being stored, which is to be like shifted, which is to be transmitted further. So you can see operation read and write. So register select, that is associated with the read and write controls, and register selection, that is a function as it is being shown over here, right? So this is how you can explain this particular block diagram. What is the function of each and every unit? As I've told you that the status register means from here the condition of flip-flops can be read out, and accordingly the different types of error, if there is any error occurred during the transmission, that would be read out. So there are three possible kinds of error which any interface may encounter. First is the parity error. Parity error means if the number of ones in the received data is not on the correct parity, means odd parity or even parity. Second is the framing error. Framing error, this kind of error occurs if right number of stop bits is not detected at the end of the received characters. If there are suppose 4 stop bits and the detected number of stop bits is 3, so it means there is a framing error. Third is overrun error. Overrun error means if CPU does not read the character from the receiver register before next one is available in the shift register. That is what overrun error means. CPU must read the character from the receiver register in the appropriate time. Otherwise, that particular data can be rewritten. So that is what the overrun error. You can just take a note about this. Thank you so much for watching this video.